Hello and welcome to today's lesson on isotopes. In this lesson, we will begin by learning what isotopes are and how they differ from one another. From there, we will explore how to represent isotopes using atomic symbols. We'll finish by understanding the impact of isotopes on the properties of elements. Previously, we discussed atomic structure, including protons, neutrons, and electrons. Today, we'll build on that knowledge by examining how atoms of the same element can have different numbers of neutrons, leading to the concept of isotopes. Isotopes are different forms of the same element. While they have the same number of protons, and hence the same atomic number, they have different numbers of neutrons. This variation in the number of neutrons gives each isotope a different mass number. For example, carbon has an atomic number of 6, which means all carbon atoms have 6 protons. However, carbon can exist as different isotopes, such as carbon-12 and carbon-14. Both have 6 protons, but carbon-12 has 6 neutrons, while carbon-14 has 8 neutrons. We represent isotopes using atomic symbols, much like the ones we used in our previous lesson. For isotopes, the atomic symbol still consists of the element symbol, like C for carbon, but the mass number changes to reflect the total number of protons and neutrons. For example, see how carbon-12 and carbon-14 are represented. The top number is changed to reflect the mass number. Isotopes of an element behave similarly in chemical reactions because they have the same number of protons and electrons. However, the different numbers of neutrons can affect the physical properties of the element. For instance, carbon-14 is radioactive and is used in carbon dating to determine the age of ancient objects. Meanwhile, carbon-12 is stable and does not undergo radioactive decay. Another example is uranium. Uranium-235 and uranium-238 are both isotopes of uranium. However, it is uranium-235 that is used as fuel in nuclear reactors because it is more prone to fission than uranium-238. Let's now solidify our understanding by working through some questions. In our first example, carbon-12 and carbon-14 are both isotopes of carbon, but which one has an atomic number of 6? So what do they have in common? How are they different? Well, both carbon-12 and carbon-14 have the same atomic number, 6, which means they both have 6 protons. Since they are neutral atoms, they also have the same number of electrons, which is 6. However, carbon-12 has a mass number of 12. Hence, the number of neutrons would be 12 minus 6, which equals 6 neutrons. Thus, we know carbon-12 has 6 neutrons, while carbon-14 has 8 neutrons. Let's look at another one. In this example, oxygen-16 and oxygen-18 are both isotopes of oxygen, but which has an atomic number of 8. What do they have in common? How are they different? Both oxygen-16 and oxygen-18 have an atomic number of 8, meaning they each have 8 protons, and being neutral atoms, also have 8 electrons. However, they do differ as oxygen-16 has a mass number of 16. Hence, we can work out it has 8 neutrons. Oxygen-18 has a mass number of 18, hence it has 10 neutrons. So our answer is oxygen-16 has 8 neutrons, while oxygen-18 has 10 neutrons. For our third example, we need to figure out if element A and element B are isotopes. Remember that isotopes are different forms of the same element, with the same atomic number but different mass numbers. In this case, the atomic numbers 6 and 7 are different, so those atoms are not isotopes. In fact, element A is carbon-14, while element B is nitrogen-14. Carbon-14 and nitrogen-14 are examples of isobars. Isobars are atoms of different elements that have the same mass number. In our final example, the diagram shows the nuclei of 3 atoms. Which of these atoms are isotopes? Let us first interpret the diagrams. We can see that atom A has 6 protons and 8 neutrons, atom B has 6 protons and 7 neutrons, and atom C has 7 protons and 8 neutrons. Remember that isotopes have the same number of protons. Hence, atoms A and B are isotopes of the same element. They both have the same atomic number, 6 protons, meaning they are both carbon atoms. However, they have different numbers of neutrons, making them carbon-14 and carbon-13, respectively. In today's lesson, we explored isotopes, which are atoms of the same element that have different numbers of neutrons. We learned how to represent isotopes using atomic symbols and how to calculate the number of neutrons in an isotope. We also discussed the importance of isotopes in various scientific applications, such as carbon dating and nuclear energy. We then practiced multiple examples where we learned how to accurately identify and compare isotopes. Understanding isotopes helps us appreciate the diversity within elements and their different roles in the natural world.